solve. We're going to make sure we check our answer. So our first example here, we have the square root of 6x minus 5. That's under the radical sign. Then minus 5 equals to 0. All right, so what we want to make sure that we do is we want to make sure we isolate the radical. We want to isolate the radical, meaning I want that square root of 6x minus 5 by itself on one side. So to isolate the radical, we're going to add 5 to both sides. And then we have here the square root of 6x minus 5 is equal to positive 5. Then raise both sides of the equation to what power to get rid of the square root? 2. Therefore, on the left-hand side, the square root and the exponent of 2 cancels out. We have 6x minus 5 is equal to 25. We're going to add 5 to both sides. We have 6x is equal to 30. Divide by 6. And we have x is equal to 5. Now to check our work, go back. We want to see if this 5 is the actual solution or if it's extraneous. So 6 times 5 minus 5 under the radical sign, then we have minus 5 equals to 0. So we have the square root of 30 minus 5. Square root of 30 minus 5, that's the square root of 25 minus 5 equals to 0. The square root of 25 is 5. And 5 minus 5 is 0. Therefore, x equals to 5 is the solution. There we go. Now our next example, square root of 3x plus 1 under the radical plus 6 equals to 0. We want to again isolate the radical. We're going to do that by subtracting 6 to both sides. And then we have here the square root of 3x plus 1 equals to negative 6. Then we're going to square both sides of the equation. And then the square root and the exponent of 2 cancels out. And we have here 3x plus 1 is equal to positive 36. We're going to subtract 1 to both sides. And we have here 3x is equal to 35. Then we're going to divide by 3. And we have the solution of x is equal to 35 over 3. Okay, so we have a solution, but we definitely want to check to see if this solution is the actual solution or is it extraneous. So on the left hand side, we have 3 times, let's check it, 3 times 35 over 3 plus 1, then plus 6 equals to 0. Well, under the radical signs, the 3's are going to cancel out, and you have the square root of 35 plus 1 under the radical equals to plus 6 equals to 0. Add 35 and 1. We have the square root of 36 plus 6 here. Take the square root of 36, which is 6. And 6 plus 6, that is 12, equals to 0. Look at this statement. That is not true. So what this is saying, because substituting 35 over 3 into this equation is telling us that the answer that we found is extraneous. Therefore, we don't have a solution. So we would say no solution. There we go. It doesn't work out at all here. And we have another example. The cube root of 2x minus 4, then minus 3 equals to negative 5. So what we're going to do, we want to isolate the radical, meaning add 3 to both sides, and we have the cube root of 2x minus 4 is equal to negative 2. How do we negate the cube root? Raise both sides of the equation by the power of 3. So the cube root and the exponent of 3 cancels out. We have 2x minus 4 is equal to negative 8. And then let's add 4 so we can solve for x. We have 2x is equal to negative 4. Divide by 2. And we have x is equal to negative 2. So that's what we have as a solution. Now let's go ahead and check this off here. So we have check our solution. Go back to the original equation. The cube root of 2 times negative 2 minus 4. That's under the radical sign. Then we minus 3. We want to see if it's going to equal to negative 5. Under the radical sign, we have negative 4 minus 4. And negative 4 minus 4 gives us negative 8. The cube root of negative 8 is negative 2. Then we have minus 3 equals to negative 5. And negative 2 minus 3 is negative 5. This is a true statement. Therefore, our answer stays is x is equal to negative 2.